Okay, in today's video, I'll be answering questions 5 to 8, 9, or 10. But 5 question says what? State the condition that the roots of this equation shall be equal. If the equation this equals 0 has equal roots, prove that the roots of these equations are also equal. So I'm just to test for equal roots basically. And in that case, solution, the condition for equal roots is when my b squared minus 4ac is equals to 0. That's for equal roots. Now in this case, what do I have as my b? My b here is 2b, because that's the coefficient of x with power 1. So that's 2b all squared minus 4. My a in this case is a, and my c is what? Is c. So if this is what I have equals to 0, this becomes what? 4b squared minus 4ac equals to 0. Since 4 is common to these two of them, it means I can say that what? B squared minus 4ac is equals to what? 0. Okay, as simple as that. For number next, what do we have? If the equations this has equal roots, this also has equal roots. So let's solve for this also and see what our answer will be in this case. Now it has been arranged for us also. When my b squared minus 4ac equals 0 as the condition of what? Equal roots, I have my b to be what? 6ab. So this becomes 6ab all squared into what's my a? My a is a squared, and my c here is what? AC plus what? 8b squared equals 0. Now on expanding, this becomes what? 36 a squared b squared minus, expanding this becomes what? 4a cube c minus 32 a squared b squared equals to what? Equals to 0. Subtracting this, what do I have? I have this as what? 4a squared b squared, because they have the same what? Coefficients, or the same variables, I mean, in that case. Then what remains? Minus 4a cube c equals to what? 0. Now on collecting like terms, what do I have? 4a squared is common. What remains? B squared minus what? 4ac equals to what? 0. It means my b squared minus 4ac is equals to 0 if I divide both sides by what? 4a squared. Now, finally, now, the answer I have to prove that the roots of this equation are also equal. The first thing I have to do is what? Bring this on here, split it into x and x squared and constants. Then what? Use this formula and get my answer. Expanding this becomes what? AC into that x squared plus 2x plus 1, then minus 4b squared x equals to what? 0. Okay, so this is what I have. After expanding the one that has squared and bring the one from the right hand side to the left hand side, expanding this becomes what? CAX squared or ACX squared plus 2ACX, then plus what? AC minus 4b squared x equals to 0. Now, for x squared, I have ACX squared. For x, I have this and this, so plus 2ACX minus 4b squared x. For constant, I have what? Only AC is equals to what? 0. Now on grouping this, it becomes ACX squared plus, if I say x comes out, what remains? 2AC minus what? 4b squared equals to, plus AC equals to what? 0. Now I now have it in terms of A, B, and C. Now using b squared minus 4AC to be equals to 0, what do I have? My b is what? 2AC minus 4b squared all squared, then minus 4. My a is what? AC. My c is what? AC. This is my a, this is my c, so it's equals to 0. On expanding this, what should I have? I should have this as 4a squared c squared minus 16ab squared c plus 16b raised power what? 4. On expanding this, what remains? Minus 4a squared c squared on expansion. Then finally, now what do I have? This cancels this out, positive and negative. What remains? 16b raised power 4 minus 16ab squared c equals to 0. Collecting like terms, I have what? 16b raised power 2. What remains? B squared minus what? AC equals to 0. Dividing, I'm going to have b squared minus what? AC to be equals to what? 0. Okay, number 6 question say we should show that this is equals to this and this is equals to this if gamma and delta are the roots of this equation, ax squared plus 2bx plus c equals to 0. Okay, simply put, I'll be using completing square method to solve this question and then prove all this thereafter. From ax squared plus 2bx plus c equals to 0, applying completing the square, what does it mean? I'm going to have what? I'm going to have this as x squared plus 2bx over a equals to minus c over a. Thereafter, this now becomes x squared plus what bx over a equals to minus c over a. If I have the x term, then this now becomes x squared plus bx over a plus b over a all squared equals to minus c over a plus what b over a what all squared. If I add the square of the coefficient of x to both sides, this now becomes x plus b over a all squared equals to minus c over a plus b squared over what over a squared. On finding the LCM for the right hand side, what do I have? It becomes what? AC plus what? B squared over what? A squared. Now, find the square root of the right hand side. This becomes what? The square root of what? B squared plus AC, or AC plus B squared over what? Over A. Now, B squared plus AC over what? Over A. Now, this now becomes what? This is plus or minus here. X now becomes what? Minus B over A plus or minus what? The square root of B squared minus AC over A. Now, let's now split it to what? Gamma and delta. Now, you can now say, let gamma be what? Equals to minus B over A, that's for the two roots now, plus the square root of what? B squared minus AC over A, and let delta be equals to what? Minus B over A minus the square root of what? B squared minus AC all over A. Now, performing what I was told to perform, that's adding and multiplying, it means that from this solution, gamma plus delta now becomes what? Minus B over A plus B squared minus AC over A, plus AC, I mean, this is plus. Okay, so B squared plus AC over A. Now, B squared plus AC over A, then I'm adding, isn't it? So that's minus B over A minus B squared plus what? AC over A, because I am adding. Now, what does this now become? These will cancel themselves out because they are actually identical. So this should be plus. They will cancel themselves out. So I'm going to be left with what? Minus 2b over what? Over A. We find the LCM of this two very, very well. So, and that has proved my question in this first case. Now, second case is to prove that what? Multiplication of this and this is what? Minus c over what? Over A. Now, it means to show that what? Minus b over A plus b squared plus AC all over A times minus b over A minus b squared plus what? AC over A would give us minus c over A. Multiplying, if you multiply very well, you're supposed to have what? Minus b over A all squared, then minus b squared plus AC all over what? A squared. When you multiply this and this, will cancel out. So I will be left with the square of this minus the square of this, or this, whichever. So this now becomes what? B squared over A squared minus what? B squared plus AC over what? A squared. Note, this minus is for these two of them. On finding the LCM, I have A squared up here. I have B squared minus AC. So that now becomes what? That now becomes minus AC over what? A squared. On solving, my final answer becomes minus C over what? Over A. And that is the solution to what? This question. Okay, so for number 7 question, it says alpha beta are the roots of this equation. Find without solving the equation this and this. Now to find without solving the equation means I should know what my alpha plus beta is, and I should know what my alpha beta is. So alpha plus beta in this case, as it is minus b over a, becomes minus b here is minus 7 over a is what? 1. Then and this is what? 7. Then alpha beta, which is what? C over a becomes what? 2 over 1, which is what? Which is 2. Now that is what I'm going to be using in this solution. Now alpha squared plus beta squared, remember, can be represented as what? Alpha plus beta all squared minus 2 alpha what? Beta, which becomes alpha plus beta is what? Is 7. So 7 squared is what? 49. Minus alpha beta now is what? Is 2. 2 times 2 here is what? Is 4. On subtracting, I have my answer as what? 45. The number 2 question, I have what? 2 minus alpha over what? 3 plus beta plus 2 minus beta over what? 3 plus what? Alpha. Now it means I'm going to expand. I'm going to solve using LCM method here before what? Expanding, and then before inputting my values into it. So which the LCM is was 3 plus beta times 3 plus what? Alpha. All this in this becomes or remains this. So that's 3 plus alpha times 2 minus alpha, plus all this in this remains this. So that's 3 plus beta times what? 2 minus what? Beta. Now this becomes what? This becomes 6 minus 3 alpha plus 2 alpha minus alpha squared plus 6 minus 3 beta plus 2 beta minus what? Beta squared, all over 9 plus 3 alpha plus 3 beta plus what? Alpha beta. Now this now becomes, let's check our numerator. 6 plus 6 here is what? Is 12. Then we have minus 3 plus 2, that's minus 1. So that's minus alpha. Then minus alpha squared minus beta squared, all over, okay, so all over what? 9 plus what? 3 into alpha plus beta plus what? Alpha beta. And this is the same thing as what? 12 minus alpha plus beta minus alpha squared plus what? Beta squared, all over what? 9 plus 3 into alpha plus beta plus what? Alpha beta. Now putting our values, what do we have? This becomes 12 minus alpha plus beta is 7, then minus alpha squared plus beta squared have been gotten to be what? 45. Everything all over 9 plus 3 times alpha plus beta here is what? Is 7, plus what? Alpha beta is what? Is 2. On subtracting, what do I have? This is minus 52. 12 minus 52 here is what? Minus 40. So, and that's over what? 9 plus what? 9 plus 21. That's 30, 32. So, I believe on dividing, what do I have? 4 can go here 8 times. 4 can go here. 4 times 8 is 32. 4 times 10 in this case is 40. So, and then 2 can go here 4 times. 2 can go here what? 5 times. So it means that my answer is what? Minus 5 over what? Over 4 for number 7 question.